another episode in better learning through pictures and through trying to explain to others. And you will find that you don't really understand something until you've tried to explain it to somebody else. So I'm going to try and explain the Riverpod implementation for the to-do example in hopes that I will understand and you will understand how Riverpod works in this and how you can use it yourself. And this is more complicated than the counter and the random number examples I did the other day because they only have one field and one action. So in this one, the UI, right, we have a text field at the top. You can type in what needs to be done. You type into that under bar area. When you hit enter, a to-do is created. The to-do app actually has a list of to-dos, and that list of to-dos can be displayed on the screen through filter criteria. So we have a list of to-dos, we have a filter criteria, and then we have a filtered list of to-dos. And that filtered, the original list of to-do and the filtered list of to-dos are basically lists of to-do items, right? So we have a to-do list filter, we have a list of to-dos, we have a filtered list of to-dos, and we have to-do items. Those are really the main state that we're going to take from this, the field that's here where we enter it. We're just going to trigger an event into state somewhere, and then the display will refresh itself. So if you think about it, the number of items left to work on, it changes every time we create a to-do, and it changed every time we click and check on a to-do to mark it complete. And so that's going to be a watch on something. If we ever need to change the display or trigger a display change somewhere, then we're going to do a watch in these cases, right? And then we have the toolbar really has the number of items left, and it has 3 filter criteria. And those basically, whenever anything happens on one of those, it changes the to-do list filter, and that changes the list of to-dos that are filtered, and that changes the list of to-dos that are displayed, right? And then there's some other pieces here, like when the bottom part of the display, which is the list of filtered to-dos, that actually changes 2 times, 2 ways. One is the filter criteria changes, which changes what would filter out to the bottom, or a new item is created with no filter change. And in that case, we would add that item to the bottom if the filter applies. So when we create a new item, it may or may not appear at the bottom, but we do know that the items left will be changed. And that's really the user interface for this. So if you just, that's kind of how it works, right? We have what are the things that can take action? The text field will cause something to occur. The filter criteria cause something to occur. And the checkbox causes something to occur. We also, as we click around on those, will generate little selection items, actions in the background. But those are really the actions that can occur, or the things that cause changes. And I guess that's it. So let me take you to my picture. So there is a Riverpod graph example or package that I had never seen. I hadn't seen it documented. Maybe I didn't read enough of the documentation probably. But what it turns out is when we have a Flutter app, we typically combine view and state. But if you use Riverpod or you use any of these others, what they do is they isolate the state. So we think of the view hierarchy, we think of the display, and we think of the state as 2 different things, and we should model them and then figure out kind of how they're going to go together, right? So on the right-hand side, these aren't in any order of importance. We basically have a thing called a to-do, right? And so then everything else is a manipulation of an individual to-do or selection, knowing which to-do we're talking about for like the current one, or manipulating a list of to-dos. And then we also have a list of filter criteria. So the one at the top is the filtered list of to-dos, right? I said there is a to-do, a list of all the to-dos we have. That's actually the to-do list provider, the second one down. And then if the filter, the third one down, is applied, that will change what goes in the filtered to-do list. So you can see here we have a to-do list provider, and then we have a to-do list filter. And whenever the total list of to-dos, the to-do list provider has a change in it, right? Because you can add another item to that list, the to-do list. Or when the filter criteria are changed, the filtered to-dos will change. And so you can see there are 2 watches that top filter to-do list is doing. It's watching to see when the to-do list is updated, added or removed. They never get removed when they're added. And it looks to see whenever the to-do list filter is applied, because the list of filtered to-do is impacted by those two things, right? And then the uncompleted to-do count is really just driven by the state change on the to-dos, right? So it doesn't matter whether filter criteria are applied or not, right? The number of to-dos that we have to do is dependent on the number of to-dos we have in a certain state, and so we listen for changes on the total list of to-dos, right? So that's what we've got. We've got the total list of to-dos, the to-do list provider. We have the filters that are applied to that. We have the filtered list that is built from the filter and the to-do list, and we have an uncompleted count that is done by looking at the to-dos on the total list of to-dos, ignoring the filter criteria, tells you how many are left, right? So that's the state we have on the side, and you can see that we have, it's really cool in a way. I didn't realize you could do this. The providers actually can notify each other, and they can cause provider state changes, which would cascade into the UI. So you don't have to have like a monolithic state object. You can have a bunch of state objects that know how to talk to each other. You got to be cautious with that, but that lets you do asynchronous updates across the model objects or these state objects. And then on the left side, we have the display hierarchy. I did this with a little indenting here to remind myself. Basically, in that to-do app, we have the screen itself, which is going to be called home, right? And then in the top part, we have a text field, and then they organize this in a modular fashion. The toolbar, which is the list of to-do the filter criteria, all completed or active, and the count, those are in a toolbar. And so they built a widget hierarchy for that, and that gets inserted into the widget hierarchy on home. And then in the bottom half, we are going to end up with a scrolling view of list items, and that list, those lists of to-do items is dynamically built whenever the view hierarchy is rebuilt. We look and see how many to-dos there are, and we build a to-do item for each one of those. And so that list of to-do items is buried inside the home widget right underneath it, and then every time there's a refresh in the number of to-dos or the filter criteria changes, we change what we show in the bottom, but we create one widget for each of the items that's in the filtered list. Right. So I feel like there's an arrow missing here. I will find it later. All right. So, I know, because that loop counter is actually in the home widget. Right. So the home widget knows whenever the filter to-dos is changed, and it has a little loop inside of the display creation. It dynamically creates all the to-do items as needed. That's why there's no watcher on that one. And then there's a watcher also on there's a to-do item for each item that shows in the filtered list. There were 3 on the screen I showed before. And when the current one changes, that tells us that if somebody clicks, we know which one we're interacting with. So that's the view hierarchy on the left. What are the big things we need to watch for? We need to watch for changes that change the count. We need to watch for changes when we create something, because that's going to change the number. When the filter criteria, we're going to change the number on the number of widgets, number of to-do items on the display. Right? So on the left side, we have a watch against the filtered to-do list, because that's going to cause a rebuild. And then we have a watch on the filter itself in the toolbar, and then we have a watch on the current to do, so that we can set that current. So whenever the current to do provider changes, the individual tool item will be like, oh man, is that me? Am I the current to do? Right? And so there we go. All right. So, and then on the left-hand side, I just kind of put some notes, right? Like I called out the fact there's the dynamic creation of these to-do events based on the number that are in the filtered list. And again, a watch will drive changes in the widget hierarchy. Read is what we use on an event. You shouldn't be putting watches. There's rules around which one of these you can use in which place. You're not supposed to put watches like inside that event piece. So what we're going to, and what the read does is says go find this notifier or provider, and then get a value or manipulate the state that's inside of that provider, right? So really you're getting a provider and you're going to change the state. In the case of the state notifier provider on the right-hand side, it would actually be the state notifier that we cause the change on. So that's maybe one other thing here real quick. Oh, at the top, I didn't talk about this, is like the 40-tooth take. We always have to have a provider scope at the top, and anywhere we're going to have notification hierarchy, we need to have a widget that is bound to the Riverpod widget tree, and those are those hook consumer widgets on the left. Anywhere you see a solid line, it's a watch. Anywhere you see a dashed line, it's a read. So anywhere you see a solid line, that's where something that could drive a widget hierarchy change. And anywhere you see a dashed line, that's where we're just taking action, usually based on some user action or something that happened somewhere else. But it would be an activity. So I think that's what I've got sitting right at the 10-minute mark here. I hope this helps. This is the to-do program inside the Riverpod. And I think this is a pretty stock program. You just wired Riverpod into. But really the cool part here, right? We can separate the view hierarchy. We can separate the state into these providers. Those providers can either be basically through a service locator style pattern. They either looked up and action is taken against them, or you can watch for change on them. And whenever that happens and you're inside one of these widgets that is in the Riverpod hierarchy, you'll get rebuild. And there are notes in the code about the subtleties of these and why the provider, the state provider, the state notifier provider were used. You'll notice only one of those. Whenever you have something more complex, you use the state notifier provider and the state notifier. And for the other ones, the state provider, it means you just have kind of a simple thing you're operating against, and then the providers have their own thing that happens. So that's it. I said that already, but this time I swear it's true, and I hope this helped. Have a great day. If you need a different kind of diagram, send me a note.